Hello everyone, I am Basavaraj Magdum, currently pursuing my graduation at Sri Venkateswara College of Engineering, Bangalore in Electronics and Communication Engineering. Now I am going to present my internship experience at Kens Technology, Bangalore on radar model using ultrasonic sensor under the guidance of Professor Ashwini AM. These all are my internship agendas: certificate, introduction, objectives, plan of work, block diagram, flow chart, hardware and software components, advantages and disadvantages, application, result and discussion, conclusion, reference. It is my 4 weeks of internship completion certificate at Keynes Technology, Bangalore. Coming to the introduction, the word radar is an acronym derived from the word radio, detective, and ranging. Radar is an electromagnetic system for the detect and determine the location of the objectives and determine distance and ranges. It operates by transmitting a particular type of the waveform, a pulse modulated, and detects the nature of the echo signal. Radar is to design and develop a radar model that can accurately detect and trace objective in real time. The model will be based on advanced signal processing algorithms and machine learning techniques and will be capable of detecting and classifying various type of objectives such as vehicles, pedestrians and animals. The project will involve a comprehensive analysis of radar signal processing techniques, including pulse compression, target detection, and tracking. Coming to the objectives, to measure the distance between the sensor and an object, to detect the presence of objects within a range by analyzing and reflected sound waves. The system can determine whether an objective is present or not. To find position of an objective in relation to the sensor. To real time, allowing for quick and accurate detection and measurement of objectives. To user friendly interface that provides visual feedback on detected objectives and their distance and position. So this is my internship 4 week of work plan that I have been done, in which I have completed task and working model. Here I have mentioned work plan set for myself during the internship. In first week, I am visited to office with all my photocopies of the documents, overview of the company profile and total internship schedules. In that, assigned to the product department to amount computer. Week 2, learning the electronics components and brief introduction on safety, ISO and clauses of companies, and learned how to stuffing and working on LQS. In week 3, I learned inspection on mounted components, values on circuit boards, discussion upon the kaizens, and working project on radar. In last week, fourth week, discussion and collected the information on project, hands-on implementation and implementation of project, and obtained the output and result. This is block diagram. First, the ultrasonic sensor mounted on the servo motor to rotate at the desired angle to create range for the ultrasonic sensor to sense the internal objectives. The ultrasonic sensor and servo motor are mounted on a higher platform to detect the objects at the higher altitude with ease. The turret is created for the firing the missile on the external objectives. This is turret is mounted on the another servo motor where it's turned to the angle accurate to the detect the angle of the servo motor of the ultrasonic sensor. The angle of the servo motor and turret must be equal to the ensure the accurate firing of the missile. Meanwhile, for the visual warning, the Arduino triggers a signal to LEDs to light up, and for the auditory trigger, the buzzer creates a sound that is used as an alert system. Flow chart. Initial system. This step involves the initializing the ultrasonic sensor and servo motor by setting off the required pins and configuration their modes. Set the servo motor angle. The servo motor should be set to an initial angle that allows an ultrasonic sensor to scan a wide range. Send an ultrasonic pulse. The ultrasonic sensor sends out a pulse of the sound waves. Measure the distance. The ultrasonic sensor measures the time it takes for the sound waves to bounce back off the objective and return to the sensor. Calculate the angle. Based on the distance measured and known speed of this sound, the angle at which the object is located can be calculated. Move the servo motor. The servo motor is rotated to point the ultrasonic sensor towards the location of the object. Repeat the process. Step 3 to step 6 are repeated multiple times to scan the entire area. End the program. Once the entire area has been scanned, the program can be ended. Hardware and software components. Hardware components are Arduino Uno ultrasonic sensor, that is HCSR04, servo motor, breadboard, and connecting wires. In software components, Arduino IDE software. So advantages and disadvantages are: first, advantages. The main advantages of radar is that it provides the superior penetration capability through any types of weather condition and can be used in the day or night time. Very flexible, can be used in several ways. Stationary mode, moving mode, and two directional mode. Beam spread can incorporated many targets. Can often select fastest target or best reflection. Still very reliable. Disvad- Disadvantages are: time. Radar can take up to 2 seconds to lock on. Radar has wide beam spread. Cannot track if dec- declaration is greater than 1 mph per second. Large targets close to radar can saturated receiver. Handheld modulation can falsify readings. Switching time of radar duplexer is very crucial when targets are very close. In this situation, reflected pulse arrives much earlier than time requires to connect the receive part with an antenna by duplexer. This is the result into the reflected pulse is not received by the radar. So application: distance measurement. Ultrasonic sensor, that radar can be used to measure the distance between the sensor and an objectives in front of it. This technology is commonly used in parking sensor, drones, and robots. Obstacle detection. Ultrasonic radar can be used to detect the obstacle in the path of an autonomous vehicles or robot. This particular useful law visibility conditions such as fog and darkness. Fluid level measurement. Ultrasonic radar can be used to measure the level of the fuel in the tank or container. This technology is commonly used in an industrial application such as monitoring the level of the fuel in large tanks. Security system. Ultrasonic sensor can be used in security system to detect the presence of an intruder or unwanted objectives. This technology is commonly used in burglar alarm, motion sensor, and perimeter security system. Medical imaging. Ultrasonic radar can be used in medical imaging to create images of internal organs or tissues. This technology is commonly used in obstetrics, cardiology, and urology. Results and discussion. And radar model using ultrasonic sensor and servo motor can be used to detect and locate the objectives within a certain range of the sensor. That ultrasonic sensor emits the high frequency sound waves and measures the time it takes for the sound waves to bounce back after the hitting an object. By using the speed of sound and time it takes for sound wave to return, the distance between the objectives and the sensor can be calculated. The servo motor is used to rotate the ultrasonic sensor in a 180-degree range, allowing the sensor to scan for the objectives in the vicinity. The output of the radar model would be typically be the distance of the object detected by the ultrasonic sensor and its location relative to position of the sensor. This output can be displayed on screen or communicated to another system for further processing or action. For example, in security system, the output of the radar model can be trigger an alarm if an objective is detected within a certain distance or if an object is detected a restricted area. In a robotics application, the output can be used in to navigate the robot and avoid the obstacles. So this is the output. Coming to the conclusion, in conclusion, the radar model using ultrasonic sensor and servo motor is the great demonstration of how the simple components can be used to create a complex system. The ultrasonic sensor is used to detect objectives within its detection range, and servo motor is the used to rotate the sensor in an 180-degree sweep. The sensor readings are then proceed to determine the distance, location, and motions of the objectives. This model can be useful in a variation application such as an robotic security system, navigation system, and even in automotive industries. It provides an efficient and cost-effective way of implementing a radar system that can accurately detect the location and motion of the objectives. Overall, the radar model using ultrasonic sensor and servo motor is an excellent example of how technologies can be used to create innovative solution to complex problem. It is simplicity, affordable, and versatile versatile make it an valuable tool for the researchers, engineers, and hobbyists alike. So this is our references I have took. Thank you.